Well, welcome back. Usually I don't go over the homework like this, but on this one, getting started here on the bonding, I felt like we should take a look at this. And so in this example on this homework, it says look at the Bohr models below and move the electrons from one model to the other as they would if the two atoms bonded. So first we look at this first atom, and on this inner energy level are 1, 2 electrons. And then on this second energy level is 1, and then we have 2, and then we have 3, and then we have 4, we have 5, we have 6, and we have 7, and we have 8. And then on the outside energy level, we have 1, 2 more. And over here, there's 1, 2 on the first energy level, and then there's 1, 2, 3, 4, 5, 6. So the atom on the left would have a full outer energy level if these two were gone. And the atom on the right would have a full outer energy level if there were 2 more. So this is what's going to happen during ionic bonding. This electron is going to go over here, and this electron is going to go over here. Now, when that happens, okay, this electron now has a full outer energy level of 8. And so does this one. We have 6 that we counted before, plus 1, 2 is 8. But something has happened. They're no longer a neutral atom. Over here, we have 12 protons in the nucleus because that doesn't change. But now, we only have 10 electrons left. 2 on the first energy level, plus 1, 2, 3, 4, 5, 6, 7, 8 on the second energy level. So that's a total of 10. And it says, what is the difference? Well, we have 10 positives and 10 negatives, so our difference is 2 positive. Over here, the nucleus hasn't changed, or we'd be completely changing the identity of the element, so it still has 8 protons. Now it has this 2 electrons plus 1, 2, 3, 4, 5, 6, 7, 8. Well, 2 plus 8 is 10. Okay, so with the 2 electrons that it gained, okay, it now has a total of, it had 8, and now has a total of 10. And what's the difference? The difference is 2 ionics. Okay, we have 2 extra electrons. So the question says, how many will A lose? Well, A lost 2 to have this remaining full energy level. And how many did B need to gain? Well, B had 6, and in order to fill up this outer energy level and have 8, it needed to gain 2. So now this is the question, and this is what we were looking at in the notes, is what is the oxidation number? Well, that's it right here. It's the change when the atom lost or gained electrons. So when A lost 2 negatives, it became a 2 positive. And B gained the 2 negatives, so it became a 2 negative. And then it says, what will be the total charge of the compound formed? Well, when this makes a compound, we're going to have the 2 plus combined with the 2 minus, and the total charge of the compound is going to be 0. When atoms lose or gain electrons, that is an ionic bond because they were transferred. So we actually physically, in this case, by dropping them over here, transferred them. And then it says, what is for families 1, 2, 3, and 4? Okay, how does their oxidation number relate to their group on the periodic table? Well, the oxidation, this is family 2, and it's the same as the oxidation number. So for families 1, 2, and 3, the oxidation number is equal to the family number. And for families 5, 6, 7, and 8, okay, over here, this was in family 6, and it needed to gain 2 electrons. So the oxidation number is the family number 6 plus the number of negative electrons to get to a total of 8. So it's equal to the number of electrons needed to fill the outer energy level with 8 electrons. Okay? Now, the characteristics of ionic compounds. How is the compound formed? Up here in an ionic compound, electrons were transferred. Co, we discussed in the notes, means to share, so electrons are shared. Now, the smallest particle involved in either of these bondings are electrons, whether they're transferring or sharing. Ionic compounds like sodium chloride, which is table salt, are solids. And we haven't really said this specifically in the notes yet, but we said water is a covalent compound, so like liquid, and then, because it's asking about room temperature, and we said things like O2, N2, H2. Well, O2 is the air we breathe, so they're also gases. So if you look at their states, they're almost exactly opposite. So we can check our work. Looks like we did a good job, and we're going to the next page. Now, on this page, okay, I ask you to actually take a look and use the oxidation numbers to name some compounds and come up with the formulas. I put a link here to the periodic table, and you can see the oxidation numbers for the different families. So this will be useful as we do this sheet. Okay, so the first one says we're going to bond sodium and chlorine. We look over here, we find sodium is in family 1, so it has 1 valence electron, and chlorine is right here, it's in family 7, and its oxidation number is 1 negative. So we're going to put in sodium symbol is Na. It's in family 1, it has 1 valence electron, and its oxidation number is the same as the family. Chlorine, we just saw, was in family 7, so it has 7 valence electrons, and its oxidation number is equal to the number of electrons to get to 8. So it needs 1 negative charge to total 8. Already has the 7. So the first step to coming up with the formula is to write the symbol, which is Na, with its oxidation number, which is 1 plus. The other one is Cl, and its oxidation number is 1 negative. So we're just using this information that we have right here. Now, the formula is going to be, we're going to use the same symbols, Na and Cl. And this is where I said, you're going to take this 1 and put it right here. You drop the sign, and you're going to take this 1, and you're going to stick it right there and drop the sign. So we're going to put a 1 here and a 1 here. Now, okay, in like high school chemistry, you would not put the 1s because like in math, if it's 1x, you don't have to write 1x, you just write x. So you would just write NaCl. The 1s don't make it wrong. Okay? It's 1 sodium and 1 chlorine. And the name of this compound is, we always use the name of the first element, the name of the metal, sodium, sodium, and then we put IDE on the end of the second one. So it'll be CHLORIDE. Now, for the second one, we're doing magnesium and oxygen. So we're going to look at the periodic table. Magnesium is right here. It's in family 2, has 2 valence electrons, has an oxidation number 2 plus. We go over here, there's oxygen. In family 6, has an oxidation number 2 negative. We're going to come over here, symbol is magnesium. It's in family 2, has 2 valence electrons. And for families 1, 2, and 3, we said the oxidation number is the same as the family number. Our nonmetal is oxygen. We just looked, it was in family 6, it has 6 valence electrons. And on the last page, we said for families 5, 6, 7, and 8, it's the number of electrons needed to total 8. Well, we have 6 electrons. 2 more would get us to a total of 8. So now we're going to write the symbols, Mg, with its oxidation number 2 plus, and O with its oxidation number 2 negative. Now we're going to write the formula. Okay, so we're going to use the same symbols, Mg and O. Now remember, when these combine, they're combining so that they make a zero compound. And the little trick that I gave you was you take this 2 and you put it down here, and you take this 2 and you put it down here. Okay? But we can simplify this. Okay? They're both 2, so we can simplify this to 1. And when the numbers are the same like this, okay, you simplify to 1. And I put a little clue right here in the worksheet. Okay, so we're going to do that. We're going to simplify to 1. Okay, so it takes 1 plus 2 to cancel 1 negative 2. And the name of our compound is going to be magnesium. And then we put IDE, OX, IDE, magnesium oxide, which is just basically magnesium rust. It actually is kind of a white substance. It's what they use in a lot of suntan oil. Okay. Beryllium and bromine. So we got to look at the periodic table and find beryllium and bromine. Beryllium is right here in family 2. It has an oxidation number 2+. Bromine, anything with an ene on it, is over here in the halogen. So here's bromine. It's in family 7, and its oxidation number is 1 negative. So we're going to go back here and use that information. Beryllium, symbol is Be. Family 2 has 2 electrons, and in family 1, 2, and 3, the oxidation number is equal to the family number. Bromine, we found out, was in family 7, so it had 7 valence electrons. The oxidation number is equal to the family number plus how many to get to 8. So we need 1 electron to get up to 8. Okay, and now we have beryllium, and its oxidation number is 2+. That's the first step in coming up with a formula. And the symbol of the other one is bromine, and its oxidation number is 1-. Now, what I told you to do is you're going to take this 2 and you're going to stick it right here, and you drop the sign, and you're going to take the 1 and you're going to stick it right there. So we're going to come up with the EE, and we're going to take this 1 that was here, and we're going to move it down over here, and we're going to take the BR, and we take this 2, we're going to move it right down there. So this is going to be a 2 right there. And then this comes out to be a 0 compound. 1 positive 2 cancels 2 negative 1s. And the name of the substance is beryllium. And then we take the name of the second thing, and we add IPE to the end. Beryllium bromide. The next one says for us to do potassium and phosphorus. We got to look at the periodic table and find out where they are. Potassium is right here in family 1, so its oxidation number is 1. And phosphorus is right here in family 5, so its oxidation number is equal to the number of negative electrons to get to 8. So we're going to come back over here. We're going to put this in here. Potassium is A. It's in family 1. It is 1 valence electron. In family 1, 2, and 3, the oxidation number is equal to the family number. And then the symbol for phosphorus was P. It's in family 5. It has 5 valence electrons. The number of electrons necessary to get to 8 is 3. And we're going to write our elements with their oxidation numbers. So we write K with its 1+. We write P with its 3. P with its 3 negative. Now to come up with a formula, we're going to use the same symbols, the K and the P. And we're going to take this 1 and we're going to stick it down here. We're going to take this 3 and we're going to put it right there. So we're going to put a 3 in this box and a 1 in this box. So we're going to put a 3 right here. We're going to put a 1 right here. Now if you think about it, what this is saying in the formula is there's 3 1 positives and 1 3 negative. That makes it total 0. And the name of the compound is potassium. phosphide. Okay, so again, you take the name of the second thing, and you add IDE to the end. All right. Well, we'll pick up next time, and hope you have a great day.